So in this video, we will talk about the power line carrier communication. We will also discuss why the power line carrier communication is important, although it has lot of disadvantages, but still the PLCC is being utilized in various segments of the smart grid network. So let's see first what is PLCC technology. So PLCC is nothing but power line carrier communication. PLCC system uses the same high voltage transmission line which is connecting two substations for telecommunication purpose also. Here PLCC is used in power utilities as a primary communication service for long distance transmission, especially if you want to send information or the voice from one substation to other substation. PLCC is effectively utilized. So PLCC is used to transmit speech, telemetry, or maybe the protection tripping commands from one substation to other substation. It is economic and reliable when we have long distance transmission, especially when you have intergrid message transfer as well as low bit RTU signal transfers. So in this case, the substations which are at very long distance, wired communication using PLCC is economical because you need not to invest on the carrier wire that is already laid in the form of transmission lines. You will utilize the existing transmission lines for exchanging the information. Here, voice and data are mixed with radio frequency carrier, which is typically in the range of 40 to 500 kilohertz. So these carrier waves are utilized to mix the data, and then it is amplified to the level of 10 to 80 watt RF power, and it is then injected in the high voltage power line using suitable coupling capacitor. What is the coupling capacitor? We will come to know in the next slide, and why we use it, that we will see. The power line as a rigid long conductor parallel to the ground guides the carrier wave to travel along the transmission line. So here point to point communication take place between two single sideband transceivers at the both ends. Now let us see the architecture of PLCC system. So here we will see what are the various components we have to send the data as well as voice over transmission line. So the role of PLCC terminal is to translate voice and data into high frequency carrier. So the output which you get from PLCC terminal in the range of 10 to 80 watt. From PLCC terminal, high frequency carrier waves goes to line matching unit. The role of line matching unit is to match the impedance of the coaxial cable which is connecting PLCC to LMU, and this coaxial cable contains the data, and then the data goes to the transmission line. So we need line matching unit to match the impedance of coaxial cable and the transmission line. It will also help in protecting the downstream terminals which are not connected to high voltage transmission line, essentially the data equipments. So it will have the high protection devices like drainage coil, lightning arrestor, and earth switches. Now from a line matching unit, the carrier waves goes to coupling capacitor. The coupling capacitor is nothing but the capacitor voltage transformer known as CVT. It couples high frequency carrier with power line so that these carrier waves can travel effectively on the transmission line. It will also help in blocking the high voltage signals which are entering to PLCC terminal. After that, high frequency carrier wave will be injected into the transmission line. Now here we need another equipment called line trap, because the carrier wave which you are injecting into the transmission line can go in this direction or maybe in the opposite direction. So in the opposite direction where we have the bus bar and other equipments, we do not want the carrier wave to go to those equipments. So for that we will utilize the line trap. So it will not allow the transmitted high frequency carriers to enter inside the substation. If we do not use, then the high frequency carrier may get bypassed to some other line or may lead to ground also. So line trap is essential to not to allow the high frequency carrier waves penetrating into the substation. Now the line trap. So line trap is designed in such a way that it offers high impedance to the PLC signals and offers low impedance for the power signals. So that's why the high frequency PLC signals will get blocked in the line trap, and the 50 Hz power signal will be bypassed to the substation. So here you will see that the various components like the corona ring is there. This is the main coil which has the tuning device, the tie rod, protective device, and you have the bird barrier so that bird doesn't go inside the line trap, and the other components for fixing the line trap to the line. Now let's see the LMU. So LMU will offer the impedance matching and the high voltage protection. So if you see, the line matching unit has the connection at one side coaxial cable, and at the other side you will have transmission line coming via coupling capacitor. So here the connection where the coupling capacitor you connect, another part is grounded. Then you will see various components like grounding switch, arc gap, lightning arrestor, drain coil, and the transformer. So using this arrangement, it will prevent the dangerous potential, that is high voltage, to penetrate inside the PLCC terminal, and it will match the impedance of PLCC with the coaxial cable. Now let's see the various PLCC standards. Here you can refer IEC 60353 for line trap. You can refer IEC 60358 as coupling capacitor, and IEC 60481 you can refer for the coupling device, that is our line matching unit. So this architecture you will see in IEC 62488-2 2017. The PLCC terminal is defined in IEC 62488-2/3. So this standard applies to amplitude modulation single sideband, that is SSB based analog power line carrier communication terminals, and the systems which are used to transmit the information over extra high voltage or medium voltage lines. It covers baseband signals bandwidth between 4 kHz to 2.5 kHz or multiple of those frequencies corresponding to the same high frequency bandwidths for single or multiple channel terminals. Let's see how the transmission and reception of PLCC data happens. So at the transmission side you will have input signal and the carrier signal which will get modulated with the help of modulator, and then the filter block will filter out the signal, amplifier will amplify, then it goes to the line matching unit, and from line matching unit it goes to coupling capacitor, and then it is transmitted via transmission line. Now at the receiving end, the signal will first get amplified, then it is demodulated, then it goes to audio amplifier, and then the power amplifier. Then after that it is directed to either for voice related activities or maybe for the data related activities. Now let's see what are the various types of coupling we have in case of PLCC. So first type is phase to ground coupling. So in this case we will use one phase of the transmission line for transmission as well as reception. At the transmission side, we will have the PLCC panel which will club the voice or data with the carrier wave, and then via line matching unit it goes to coupling capacitor and then it travels, and then at the receiving end via coupling capacitor and line matching unit it goes back to the PLCC panel. In case of face-to-face coupling, the transmission and reception of the data happens at different phases. In third type, we have interline coupling. It means that the substation might be having two sets of transmission lines where one phase of one line can be used for transmission and other line can be used for reception. So two different sets of transmission lines will be utilized for the transmission as well as reception. Now let's talk about the data communication classes which we have in case of PLCC communication. So first class is the broadband. Here the operating frequency ranges between 1.8 to 250 megahertz. Generally we use this kind of solution for residential internet access. We also use it for smart home data communication and creation of the home area network also. This is good for short distance communication. Typically it can go up to few kilometers, but because of lot of attenuation factors involved, it ranges within a kilometer only. The application which uses the broadband class of PLCC communication is advanced metering infrastructure or the automatic meter reading, or in the case of smart home data communication. But it is not good for substations because it cannot travel longer distance. Next is narrowband. It operates between 3 to 500 kilohertz. Data reporting rate is up to 500 kbps. This kind of communication is used for communication between substations. The third one is ultra narrowband, where the operating frequency is 30 to 3 kilohertz and data rate is up to 100 bits per second, which is very low, but it is good enough for sending the commands or activating any device, particularly in case of demand response program. Also in case of AMI, where we need less data to be reported, in that case also the ultra narrowband can be utilized. Here the communication range is large. Theoretically it can go up to 150 kilometer, but practically it will be lesser than 150 kilometer. Now what are the various factors which are affecting PLCC reliability? So reliability of PLCC depends upon the amount of power output of the transmitter type and number of parallel transmitters and receivers required for data communication, which type of LMU has been applied, type and size of coupling capacitor, type and size of line trap used, power line voltage and physical configuration of the power line, and phases to which PLCC signal is coupled, length of circuit and transposition in the circuit, decoupling equipment at the receiving terminal, type of modulation utilized to transmit the information, and the signal to noise ratio in the received signal. What are the advantages of PLCC? The biggest advantage is that there is no separate wires needed for communication purposes because the power line themselves are being utilized to carry power as well as communication signals. It is a cost-effective solution because you need not to lay the separate line for communication purpose. Power lines have higher mechanical strength, that's why they can withstand the harsh environmental condition and they will get unaffected in terms of data communication. Power lines usually provide the shortest route between the power stations. That's why substation to substation data communication can be done with the help of PLCC. Power lines have large cross-sectional area resulting in very low resistance per unit length. That's why carrier signals will suffer much less attenuation when compared with other communication lines of equal length. Largest spacing between conductors reduces the capacitance, which results in smaller attenuation at higher frequencies. Large channel spacing also reduces the crosstalk to a considerable extent. What are the disadvantages? Here the proper care has to be taken to guard carrier equipment and persons using them against high voltage and current on the lines. Noise introduced by power lines, that is basically generated by the discharge across insulator or the switching processes, is far more than in case of other communication line. So because of that, we will have lot of distortions in the data communication. Attenuation is high at the joints of power lines. So wherever we have joints, long distance communication requires a lot of power equipment isolations such as line trap and all needs to be added at each and every point where the power equipment is installed. Because of that, the overall cost may increase. Security is also a concern because the data travels over the transmission line and being a open data communication channel, the security will be a big concern. During adverse weather conditions, the corona discharge and electromagnetic interference will also cause the signal disturbances, and because of that, it is not preferred for long distance data communication. Because of that also we have the poor noise isolation as well. So we have these disadvantages which are more severe than the advantages which we have from PLCC. Because of that, the data which we send from substation to substation is not disturbance free. Further, there are lot of concerns with respect to the attenuations because whenever we have the joints in the transmission line, the data will get severely attenuated. So because of these challenges, PLCC is not effectively utilized for long distance data communication. Since it is a very good option for short distance data communication, the PLCC is now being increasingly utilized for smart meter data communication as well as the device level or the appliance level data communication within the smart home network.